The first question says wastewater can be used to produce drinking water, aka potable water. The processes used include sedimentation, filtration, and chlorination. What is sedimentation? So we know that sedimentation is when the impurities in the wastewater settle to the bottom, form a sediment in their container. So the description that most closely matches sedimentation would be C. So the answer is C. You've then been asked to give the electron configuration of the following ions, and you do need to make sure you take into account the fact that they are all ions, so they have a charge. So sodium, we know, has 11 electrons, but sodium 1 plus must have lost an electron to form the +1 ion, so it only has 10 electrons. We know 2 of those 10 electrons can go in the first shell, which leaves 8 electrons to go in the second shell. Chlorine has 17 electrons, but chloride has got a -1 charge, so it must have gained an electron. So the chloride ion actually has 18 electrons. We know 2 can fit in the first shell, 8 can go in the second shell, which leaves 8 to go in the third shell. So the electron configuration of chloride is 2, 8, and 8. Magnesium has 12 electrons. However, Mg2 plus has clearly lost 2 electrons to get the +2 charge, so it's only got 10 electrons. Out of these 10, 2 can fit in the first shell, which leaves 8 to go in the second shell. And the little hint you can use in the exam is all ions will have either lost or gained electrons to get a full outer shell. So this final shell, in all 3 cases, should be full, which here they are. You were then asked whether calcium chloride can conduct electricity and to explain your answer. The first thing you need to do is decide what type of bonding is present in calcium chloride. Calcium is on the left-hand side of the periodic table, therefore it's a metal. Chlorine is on the right-hand side, so it must be a non-metal. So calcium chloride must be ionic because it's between a metal and a non-metal. In terms of answering whether ionic compounds can conduct electricity, we know even though they have ions in a solid, the ions are in a fixed position. So ionic compounds cannot conduct when solid because the ions are in fixed positions, but they can conduct when liquid or aqueous because those ions are free to move. You've then been asked, can carbon dioxide conduct electricity, and explain your answer. So again, we need to decide what type of bonding is in carbon dioxide. Well, I know carbon is a non-metal because it's on the right of the periodic table. Oxygen is a non-metal, and the bonding between 2 non-metals is covalent. It's not diamond, graphite, or graphene that we've been asked about, so I know it's simple covalent or simple molecular, and I know simple molecular can never conduct electricity because there are no free ions or electrons. So in this lesson, we're going to be looking at metallic bonding. So it's the third and final type of bonding we need to consider when explaining how metals behave, their properties, and how they are used as well. So we know from our lesson on the periodic table that everything to the left of our staircase divide in red, so from aluminium, they are all metals. And everything to the right we know is a non-metal. So if you look at group 1, with the exception of hydrogen, so hydrogen is not a metal, it's only there because it's got 1 electron, so please don't mistake that for a metal like the rest. But if we look at group 1, from lithium to francium, we know they have 1 electron in their outer shell. They lose 1 electron to form a positive ion and gain that full outer shell. If you look at group 2, we know they've got 2 electrons in the outer shell. They lose 2 electrons to gain a full outer shell and form a +2 ion. And it's the same with group 3. So when metals form ions, they always become positive. So metals will always lose electrons when they form ions. They will never accept electrons. And it's really important that we're aware of that fact. Now, in ionic bonding, when a positive ion lost electrons, it gave it to the negative ion. There is no negative ion in metallic bonding. So those electrons aren't being transferred to an oppositely charged ion because in metallic bonding, there's only the metal. So metallic bonding is only when you have a metal by itself. And that again is your test in the exam. So if you were asked about sodium by itself, sodium has metallic bonding, magnesium has metallic bonding, aluminium has metallic bonding. So you need to realise metal plus non-metal is ionic, non-metal plus non-metal is covalent, and a metal by itself creates metallic bonding. What we've just mentioned, in an ionic compound, we've got negative ions that want to gain them. Here we don't. So those electrons go to what we call the C. So metallic bonding is the strong electrostatic force of attraction between your positive metal ions, as shown by these plus charges, and your C of delocalized electrons. So using the periodic table, we've just explained that metals always lose electrons when they form ions. So all of these metal atoms lost these yellow electrons to form these positive ions. These electrons then go into the C of the structure, so they flow in between all of these ions, and they're delocalized because they can move. So that is the structure of a metal. That's what holds a metal together. And they form this giant metallic lattice. So we have hundreds of these positive metal ions surrounded by our sea of delocalized electrons. We know electrons are negative. These metal ions are positive, and we also know opposites attract, and that gives rise to our electrostatic force of attraction between our positive ions and our negative electrons. You can be asked to draw this in the exam, or you can actually give your drawing as your answer, but just make sure the key requirement when you draw it is you must include a minimum of 6 particles, so 1, 2, 3, 4, 5, 6. They must be in rows because the positive metal ions align in a regular arrangement of rows, and for each positive ion you need to have your delocalized electrons flowing around them or between them. So those are the marking points you need to make sure you hit if you are asked to draw a diagram to show metallic bonding. So if we've got a strong electrostatic force of attraction between positive ions and a sea of delocalized electrons, we know the melting point of all metals is going to be high. And the reason is that there is our strong, so we're just putting in our definition again, which is why it's really key to make sure you learn those yellow boxes, because we've got a strong electrostatic attraction between the positive metal ion and our negative delocalized electron. The big mistake here is students confuse metallic bonding with ionic bonding. In an ionic compound, the electrostatic attraction is between a positive ion and a negative ion. Here, the electrostatic attraction is between a positive ion and an electron. So it's very different. There are no negative ions for metallic bonding. So you need to make sure you don't write that in your answer. If we have a sea of delocalized electrons, that means the electrons can move and carry a charge. So metals can conduct both when solid and when liquid. And they're the only compound, the only type of bonding we've looked at that can do this. So pause the slide and have a go at reading these practical applications of chemistry from the Royal Society of Chem. Answer the 3 questions and then I'll go through the answers. Okay, so we know H2 involves 2 hydrogen atoms. They are both non-metals, so the type of bonding would be simple molecular or simple covalent. You were then asked to compare the number of subatomic particles found in a hydrogen 1 atom and a hydrogen 2 atom. So we're comparing our isotopes. Well, in a hydrogen 1 atom, we've got 1 proton, 1 electron, and 0 neutrons. Okay, and the reason we've got 0 neutrons is because if the mass number is 1, the atomic number is 1. To find neutrons, it's mass number take away atomic number. 1 take away 1 is 0. So there are no neutrons in an atom of hydrogen. If we look at the H2 isotope, we're going to have 1 proton, 1 neutron, and 1 electron. And that's because the mass number this time is 2. The atomic number is 1. 2 take away 1 gives you 1 neutron. And then you've been asked to describe what metallic bonding is, and we know it's the strong electrostatic force of attraction between the positive metal ions and the sea of delocalized electrons. So that brings us to the end of the different types of structures and bonding we've looked at this topic. So what we now need to do is bring it all together by looking at the 6-mark question where you've got to include in your answer all 3 types of bonding using the information in the table. So pause the slides, have a go at answering the 6 marker, and then we'll run through the mark scheme together. Starting with A, we can see the melting point of A is high. We know A doesn't conduct when solid, but it does when you melt it. Therefore, A must be ionic. It's got a high melting point because of the strong electrostatic force of attraction between oppositely charged ions. It doesn't conduct when solid because the ions are in fixed positions. It does conduct when molten because the ions are free to move and carry that charge. That's what you need to state for substance A. And you're looking at 2 marks for this. Moving on to substance B, we've got a high melting point. It can conduct when solid and it can conduct when liquid. B therefore must be a metal and must display metallic bonding because only metals can conduct both when solid and when molten. And your explanation for that is it can conduct because it's got delocalized electrons which can carry the charge. It's got a high melting point because of the strong electrostatic force of attraction between the positive metal ions and the sea of delocalized electrons, which needs a lot of energy to overcome. So now you're looking at 4 marks for getting A correct and B. You would not get many marks at all if you just state A is ionic and B is metallic. You need to explain your answer. C then has a low melting point, does not conduct when solid, and does not conduct when molten. Therefore, C has to be simple covalent. It doesn't conduct when solid or molten because there are no free ions or electrons. And it's got a low melting point because there are weak intermolecular forces between molecules which require a small amount of energy to overcome. So for all of this, you're looking at 6 marks. You need to talk about A, B, and C, but explain your answer. So it would not be enough to say C is covalent. You need to say because it's got a low melting point and explain why, and explain why it doesn't conduct. So that's what you need to get all of the marks.